And this corresponds to one of the problems in the document. And of course, this video is going to be embedded in its document, and I didn't write the date down here, and it's been a little while, so I don't remember what the date is, so I'm going to have to do this without writing the date. But I'm estimating somewhere around 1704, less than 10, 0401 to 0409 someplace. Be one of those documents. Okay. Now, the idea is that we have divided our target into 1 centimeter intervals, from -3 centimeters to -2, -2 to -1, -1 to 0, and so forth. And we've simply tallied how many times the ball hit within each of those intervals. Maybe we've got a piece of carbon paper on our target, and every time the ball hits, it makes a mark on the carbon paper so we can see how many times we hit at different positions. One way or another, maybe we have an electronic device that records. One way or another, we get these results, and the way we record our number of hits between -3 and -2, well, that's the frequency. Okay, this is just a frequency table for the number of hits. So between -3 and -2 we hit 12 times, between -2 and -1 we hit 84 times, between -1 and 0 215 times, and so forth. Now, we're going to try to calculate the standard deviation for this frequency table. And the way we're going to do that is we're going to assume that every hit here was at the center of this interval. So between -3 and -2, the middle between -3 and -2 is -2.5. Between -2 and -1 is -1.5, and so forth. So now we're going to assume we have 12 hits at -2.5, 84 at -1.5, 215 at -0.5, and so forth. And we're going to try to calculate the mean position at which the ball hit. So we multiply the middle position by the number of hits we have in that corresponding interval, and we get, in this case, -2.5 times 12 is -30. Again, this corresponds to, okay, let's assume we hit at -2.5 12 times, and we're going to add up all those 12 results. So we're going to add up -2.5, -2.5, -12 times. Well, that's the same as multiplying -2.5 by 12, we get -30. We do the same for every interval. We multiply the position at the center of the interval by the number of times we hit that interval. So if we multiply -1.5 by 84, that's the same as adding all 84 -1.5s. Okay, well, we do that throughout, and we add these up, and we get -64. And of course, we add up our frequencies to see how many times we hit, and we get 552. And then we calculate our mean by dividing the, dividing the total of all these by the number of occurrences, the 552 occurrences. And we get -0.12. So we have now a distribution with a mean of -0.012. Now, we can calculate the standard deviation, and we're experienced at doing that. And all we really have to do is then find the deviation of every one of these midpoints from the 0.12, -0.12, square that, multiply by the frequency, add them up, and so forth, and we're used to that. So I haven't written all that out. People did that very well in class, so I assume everybody understands how to do that. Well, we got a standard deviation that was pretty close to 1. So we're going to use 1 for our standard deviation. And And we tried to answer some kind of a question with that. I can't conjecture what that question is. I really ought to have the document here. And why we have 49% here and 40% here, there's some kind of a question. I don't remember what the question is, so let's just let this stand as a calculation of the mean and an indication of how we would get our standard deviation. And then we could draw our model, which we haven't done, so I'm not sure where we went with this. I'll probably come back in another video after I figure that out and address the question that was actually asked. You know, maybe even put a date up here, because I'm going to have to look up that document.